Now for the last section, what we want to do is we want to write equations that expresses the following relationship. In your equation, use k as a constant of proportionality. So it's just like the constant of variation. So let's look at example 1. Example 1 says d varies directly with the cube of w and inversely with p. What does that tell us? So in this case, d is similar to y because it says d varies directly. So right here, so it says d is equal, and since it varies directly with the cube of w, so what is the cube of w? It is w cubed. And inversely with p. So what does inversely mean? That means p is going to be in the denominator. All right, keep in mind k is always in the numerator, which is why I put it up here. There is no way, there was no information given to tell us how to solve for k. So this is our equation. Okay. So now let's look at example 2. Example 2 says p varies jointly with the square root of d and t inversely with the cube of g. So does that tell us? So p over here acts like y, so p is equal to, and then so this one's new, it says jointly. So looking at C, or number 3, it says y varies jointly as x and z. So does that tell us why this is when they're multiplied together? So again, let's put our k here. Okay. And since it varies jointly with the square root of d and t, what does that tell us? That it's going to be t times the square root of d. Right? You can also put square root of d times t, but the reason why I put t up here is because sometimes it gets kind of confusing. Like it might seem like t is right below the square root, and that would be wrong. So to eliminate any ambiguity, we just put the t first. Okay. So now the second part says, and inversely with the cube of g. So since it's inversely, we know that it has to be on the bottom, and it's inversely with the cube of g. So what is that? What's the cube of g? The cube of g is g cubed. Okay. And this is our answer.